tablespoons of sugar to coffee.
Are you serious?
Yeah.
You should cut that back.
I mean 3, not 4.
Try and drink it black.
Oh my god, that is so disgusting.
Black is good.
Well, without sugar.
Yeah.
When I was younger, so my dad drank a lot of coffee when I was little. So a lot of kids want to kind of be like their dad or mom or parents, whoever. And so I wanted to be like my dad. So when I got old enough to start drinking coffee, I did what he did. I put, you can't drink coffee when you're 10. You're not supposed to.
That's what I did.
So
I had a little.
that's a different conversation. So when I got old enough, I started drinking coffee, but I made it just like him. He had a lot of cream and lots of sugar. So then you're drinking like this creamy, sugary, hot drink. Of course, kids are gonna like that. By the way, it makes me super hyper, even better. So, so then as I got older, I started realizing this isn't really drinking coffee. So I slowly transitioned to black coffee. Now I can't even think about adding anything. Black's the way to go. Anyways, back to this. Okay, so again, real quick, if we increase temp, we're adding more energy. This side goes down. We shift to the left, like Cal said. Good job. So for number 7, we're shifting left. All right, decrease temp. So now, again, stay with me up here. We're taking the energy off, right? So if we decrease temp, that's like decreasing that number. So now we're taking energy off. What happens to this side?
It goes up.
Goes up. Okay, so now we have to shift to the right. We have to make more products to go back to equilibrium. So number 8, we're shifting right. All right. So now I'll get to 9 and 10 in a minute. Now let's talk about the N2H2 and NH3. All right. So for number 7, if we're going this direction, okay. So if we're shifting to the left in number 7, you're making more of these two, and you're using this up to make them. So the answers here would be increase, increase, decrease. N2 and H2 increase in concentration, you're making more, NH3 decrease. And then number 8 is the exact opposite of that. If we're shifting to the right, we're using these two, they're reacting to make more NH3. So these are decreasing, and NH3 is increasing. So for number 8, it's decrease, decrease, and increase. Okay, so now 9 and 10. All right, so now what we just talked about today and the other day briefly, if we're increasing pressure, and you know what? This is not very useful. The only way you could try and use the seesaw analogy is if you increase pressure, this side feels it more. So if it's feeling the pressure, it's more condensed, so it gets heavier. That's kind of a lame way to kind of use this. I don't really use the seesaw for this. I just kind of go on, memorization. What is that? If you increase pressure, we always go towards the lower number of moles. In this case, it's to the right. So increase pressure, the greater moles will try and migrate to the lower moles to spread out. So we're going right for number 9, and then 10 is the exact opposite. If you decrease pressure, now you're coming back towards the higher moles. If you decrease pressure, it has the opposite effect. So decrease pressure, we're going to the left. So number 10, you're going left. Question?
Like, why, when you decrease pressure, why are they all going to the more spot?
Yes, so it's more of a delicate situation. Okay, so when you guys were standing on this side and Ben were on that side, if I can make the room get bigger, the pressure would be lessened, right? So as things get larger, less collision, less pressure. Hopefully everyone's fine. This is not just me talking to her, pay attention please. I'm looking at her, but everyone listen. So when the room gets bigger, there's going to be a drop in pressure. That makes sense to you?
Yeah.
Okay. Well, at equilibrium, so when everything is balanced and nice and orderly and how it's supposed to be, there's a certain amount of space between the particles on this side, a certain amount of space between the particles on this side. Well, if you start expanding the room or the container so that the spaces now are getting bigger, that's not equilibrium. They want to be back to where they were. So the only way to shorten those distances is by adding more particles to that area. So that's why it goes in reverse.
Okay.
That make a little more sense?
Yes.
It's confusing. The way I teach it in AP Chem, because AP we talk about volume more than pressure, is what I just told you guys. If you can imagine the container getting bigger or smaller, the pressure is actually indirectly related to the volume. You guys already knew that though. Actually, you know, I never showed the trick. You gotta remind me when we review.
Oh yeah.
Okay? Someone else, who else was in here with her?
It was
Was
Casey
it you?
and
You?
Show the trick.
It was just us three.
Alright, yeah, so if one goes up, the other goes down. Anyways, I'm kind of going off on a tangent, sort of. I will show everyone that trick when we review gas laws. I know you did the packet already, but when we have review classes. Anyways, the answer to number 10, after all that, we're shifting left, it's the opposite. Decreased pressure, we go towards the higher number of moles. Okay, back to 9. Now, this is the part that I hope everyone understands at this point, is once you figure out the shifting, I hope you can figure out the rest of this, because we've been spending a little more time on that. So if we're shifting right in number 9, you're making more of this. So NH3 is going to increase, and then these two are going to decrease. So it's going to be decrease, decrease, increase, and then 10 is the exact opposite. If we shift left, increasing for both of these, increase, increase, and NH3 is decreasing because you're using it up. Flip it. Alright, number 7. Alright, I'm going to go through this one kind of slow. 7 and 8, and then I'm going to start going a little bit quicker through some of these. Alright, here we go. So again, eyes up here. This time, let me rewrite it. This time we have, is this endothermic? Yes, we got 12.6 kcal plus H2 plus I2 yields 2HI. Okay, now, here we go. This time we're increasing temp. Which side goes down? This side goes down. Okay, what do you want? Because I'm increasing temp. Okay, fair enough.
Because you're adding more energy.
Yeah, we're adding more energy to the energy. So here's where the energy is. That's why it's really important you know which side of the arrow this is on. So when you increase temp, you know which side goes down. Increase temp, you're adding more. Let's say the number goes up to 30. This gets heavier. We have to shift to the right to go back to being equilibrium. So number 7, we're shifting right. Number 8, the opposite, we're shifting left. And again, with me, Cody?
Yeah.
Tired from all those squats? You take some energy off. Decrease the temp. Now you're taking the energy off. You're dropping that number to, let's say, 5. So it's going to get a little bit lighter. Well, it doesn't want to be. It wants to be where it was, so we shift left. Okay? So we're shifting to the left, and that's what we do with number 8. Hey, man. Going over this sheet right here. Okay. All right. So now number 7, if we shift right, H2 decrease, I2 decrease, HI increase. And then number 8, if we're shifting left, H2 and I2 both increase in concentration, HI decrease in concentration. Questions on this one?
What number again?
We are on the back, the top chart, number 9 and 10 now. All right, now, number 9 and 10, you can't answer.
Yeah, you can.
Well, you can't.
Why not?
You're on the wrong side, Chico. 9 and 10 up top. There you go. Why can't we answer 9 and 10 on the top chart? Same number of moles. If the moles are the same, so 2 here, 1 and 2, and then 2, pressure doesn't affect it. Here's why. If there's a difference in moles and you increase pressure, it goes towards whatever side has the lower number of moles. And if you decrease pressure, it goes towards the higher moles. Well, if the moles are the same, the gas doesn't win either way. In other words, there's no out. There's no way that's better, so they just stay put. That's kind of an easy way to very simple way to explain it. Because 2 and 2 are equal, there's no difference between the sides. Pressure doesn't really affect it. Pressure won't affect it. Okay? So you can't answer 9 and 10 on the top. I did know that. I didn't tell you on purpose to see if anyone kind of figured that out or thought about it. However, I will tell you at the bottom, I screwed that up. 7 and 8 on the bottom, you also can't answer, but for a different reason, and I forgot to tell you, sorry.
Oh, I think this one.
Yeah, it tells you actually, right next to the reaction, it tells you. Remember that pure solids and liquids do not affect equilibrium values. It sort of tells you, but not really. What else does not affect solids and liquids? Pressure changes. If you look at that reaction on the bottom, NaOH solid on the left side, it's not going to be affected by pressure. And then if you look at the right side, it's aqueous, meaning dissolved in water, which is liquid, not affected by pressure. So pressure doesn't affect the bottom one either. So 7 and 8, can't answer. All right. So all we have left to go over here is 5 and 6 on the bottom. I'm going to go a little bit quicker here. So number 5, energy's on the right. So if we're increasing temp, we're shifting to the left. So number 5, we're shifting left on the bottom. Number 6, shifting right. And again, eyes up here, energy is on the product side here. If you add more energy, increase temp, that's what happens. That's why we shift left. And then if you remove some of that energy, that's what happens. So we have to shift to the right. Number 5, we're shifting left, so NaOH will increase, and then Na plus and OH minus decrease. Number 6, when we're shifting right, my NaOH decreases, but the Na plus, OH minus will both increase. Questions for me? All right, let's go to the other one. Whatever it is. Oh, who did not take the quiz yesterday?
I don't think Ginger finished.
She wrote not finished, but then I looked
Okay.
at it and it was all done, so I was confused.
She was talking about like a couple and she wasn't sure and she wasn't sure about answer.
Yeah.
So she's like, let's do that.
Okay.
We'll just-
You're not done, you said? Everyone else in here took it. Okay, good. Oh, and,
Maddie didn't.
yeah, I mean, but who's here right now? Yeah. Okay, so Maddie didn't. Anyone else you guys know off the top? I didn't really go through them all very close to
Earth.
I don't know how to spell Maddie like that. Curve, Amber, right?
Yeah.
Thomas.
Thomas wasn't here yesterday? That's good enough, thanks. This is who I have not being here yesterday. Thomas, what, Amanda or Raquel, did you guys come in late or something?
Yes, they did.
Oh,
Today?
yeah, we were, yeah.
Yeah, just because he marked you out and he crossed you off. Maddie, Amber, JoJo, Curve, and Deanna, obviously. So,
But Sylvia's
JoJo, question mark?
Yeah.
All right, here we go. Oh, and I keep forgetting.
What?
Tristan and Brian, let me talk to you after class. Okay. All right, number 1 on the other sheet. Here we go. If the concentration of oh, yeah, this is great. Good question. All right, if we add nitrogen, which way does it shift? So this is the same reaction you've seen quite a bit here. Okay, so if we add N2, what happens to this side? It goes down, so we got to shift to the right. So we're shifting right. What happens to the moles of nitrogen? Well, they increase, but then they decrease. They decrease ultimately. Good job. Now I want to show you why. Okay, you can just watch. You don't have to write this down. If we show an equilibrium curve, all right, this is kind of what it would look like.
Oh, you listen what? You got number wrong. That's supposed to be 91.1.
Oh, I did that earlier too, didn't I? Good catch. 91.8. 91.8. Gigawatts.
Oh my god.
What the hell is a gigawatt? You guys know what I'm talking about?
Yeah.
Did he say gigawatt or gigawatt? She's like, what the hell's a gigawatt? All right, back to this. I'm sorry, that just stuck in my head there. All right, now if this is the equilibrium curve or graph for this reaction, all right, which one is NH3? Which line? Top, middle, bottom?
I have no idea.
So remember the equilibrium graphs we drew the other day?
Yeah.
I put the
Oh, yeah. the
screen
two
up
in
here.
copy,
One
yes.
was red, one was blue.
Yeah.
Some of you, you're scaring me here. That was
Yes,
not
we
long
had to
ago.
draw them, and then you made us discuss with two.
Yeah. I said come together, explain the graphs. Okay.
Yep.
So, does it make sense? Here, I'll help you out. This is 0. Let's say this is a concentration of 5. This is the concentration of 6. All right, this is molarity. So, which one in the beginning of the reaction, if this is time, here's the beginning of the reaction, which one starts with no concentration? The reactants or products? Products. So this line here is NH3. That should make sense, that initially you have all N2 and H2, no NH3. As time progresses, now you're making more product and you're using up your reactants. What happens over here? This line, what does that symbolize?
Equilibrium.
Equilibrium, because everybody's constant. Because the rate is equal, you have the same amount and it's not changing, right? The same amount of NH3, N2, and H2. Okay, so which line, the top or the middle, is H2?
Middle.
Grant, you with me?
Yeah.
Good. This is H2. This line is N2 from this question. This is actually really good to go over because I saw this on a Regents once and I got a little bit flustered. I got upset because I was like, I never really talked about this. I never showed them one of these. You know, a lot of kids figured it out anyway, but I was just, I don't like it. I don't like seeing something we didn't at least go over once. This spike represents dumping a whole bunch of N2. So in number 1A, it says, okay, what if you add nitrogen? So if you have a reaction and then you dump a whole bunch of one of the reactants or products, it's going to spike on one of these graphs. Why? Because you added a whole bunch. Concentration jumps up, but then because you added more, it's going to start colliding with the hydrogen and reacting and making more products. So eventually it'll come back down. So this little spike is just to represent this reaction. So eventually, like Cody said, eventually this nitrogen will decrease. It starts out higher than it ends up. Why? Because it's reacting to form products. So I just wanted to kind of show that to you. I've only seen it once, but it's good to see, okay? Because that's what that represents. And again, the most important part about all of this is here. This is where equilibrium is established. No one is losing or gaining concentration because the rates are equal. That means the concentrations stay constant. Okay, 1B, if we increase pressure, we're shifting to the right. That's the lower number of moles. So if we're shifting right, that means H2 is decreasing. You shift right, you're using that up, H2 is decreasing. C, what if we decrease hydrogen? So if we take some hydrogen away, so now it's going to go like this, we have to shift to the left to fill in what we just removed. So we're shifting left in letter C, and that decreases NH3. You're decreasing ammonia in letter C. This is exothermic, energy's on the right. That's all you need to say. Exothermic's on the right. Or you can say it's releasing energy. That's another explanation. Exothermic, it's releasing energy. But the energy on the right is the best way to say that. And then, what is the heat of reaction? I put that on there to try and remind you. Here's your delta H, but the actual value is negative 91.8. It's negative because it's exothermic. You won't see negatives in the equation. They just don't do that. All right, so it's actually negative 91.8. A, 2A. If we increase temp, shift to the right, this way.
Please pardon this brief announcement. Modified baseball and softball games today are canceled. So we know modified baseball and softball today. Modified baseball will not practice. Modified softball, please check with your coach for the status of practice. Varsity baseball and softball games will be on at BKW as scheduled. Thank you.
Let them play. Temperatures increased, letter A there, 2A. We're shifting to the right. Why? Because the energy is on the left side. It's an endothermic reaction, that's why. All right, letter B, haven't taught it to you yet, but I was hoping you could figure it out. Sure, what do you think? If we add a catalyst, what happens to the concentration of the products?
But there would be more products than reactants.
Good. That's what everybody thinks, and that makes sense, but it's not right, sorry.
It'll remain the same.
Cody says it remains the same. Why, Cody?
Because catalyst affects something else.
Okay. So what Jerem said is logical. Oh, you add catalyst, it's going to react better, so I'm going to get more products. Makes sense. However, to really stop and think about it, so sorry, Jerem, I just called on you. I knew somebody, could have been anybody. What does the catalyst do?
Speeds it up without being.
Speeds it up, and it doesn't do anything else. It doesn't add energy, it doesn't take energy away, it doesn't increase your products, doesn't increase your reactants, doesn't decrease your products or decrease your reactants. It only speeds up a reaction, okay? It only speeds up a reaction, so it's a trick question. The concentration stays the same because, again, the catalyst only speeds up a reaction. And again, Jeremy, don't feel bad. A lot of students don't get that one right. C, which is kind of annoying because you got to flip, but if we increase the pressure now, yeah, I'll just put it up here quick. You have N2
You mean decrease.
plus, does it say decrease?
Yep.
Sorry. 2NO2. All right, so if we decrease pressure, we are shifting to the left. Shifting left. If we decrease pressure, we're shifting left because there's more moles on the reactant side. Letter D was a review question. Who thinks they got it? Who thinks they got it? Negative 32 or 33.2?
33.2.
Positive 33.2. Here's why. It says, what's the delta H for 0.5 moles of nitrogen? Well, 1 mole is 66.4. It's right over there on the left side. 1 mole of this, 66.4. So if you cut the moles in half, you cut the heat in half. So 1 is to 66.4 as 0.5 is to X. So it's 33.2 kilojoules is the answer to D. 3, the answer is 0 degrees Celsius, or 100 degrees Celsius, sorry, 100. All right, we'll pick up with that on Monday. Don't forget, review package, due Monday, atomic structure. It's Earth Day on Sunday, do something for the Earth. Don't shower, save water.
Oh, shower. Oh my god.
Recycle something, pick up garbage, use less water, turn off lights, don't use your electronic devices. Don't eat meat.
Don't eat meat. Oh my god.
Yeah, that helps the environment.
Never gave me a review package.
Animals consume a lot of water. What?
Yeah, you weren't here yesterday, and then the day before
I
you weren't
didn't
here.
give you one,
No.
or you didn't come get
No,
one.
I came in here for the homework, remember?
I just wrote random stuff.